In this video, we talk about domain name system or DNS. First of all, we talk about DNS functions and DNS server. Then we look into DNS hierarchy. After that, we discuss real-world examples. Then we see how DNS works. Finally, we sum up our video with the keynotes. Let's talk about DNS functions. As you may remember, DNS is a service in application layer of TCP/IP model. DNS uses UDP as transport layer and operating on port 53. DNS main function is to translate human-friendly computer host names into IP addresses. Additionally, DNS answers with IP address of the server for the service it provides, such as email server or Active Directory server. DNS also provides a central role in distributed internet services by providing the IP address of the server that is proximal to the user, which usually have better performance. In order to perform its function, DNS is usually installed on a server as a service. That server is called DNS server. DNS server stores multiple types of records for name to IP mapping in its database. For example, these are the two records. The first one is a record. It is used to translate from the DNS name to the IP address. The second one is MX records. It is for the client to query the DNS server. What is the IP address of the email server for Cisco skills.us domain? In this case, the DNS server will answer, this is the IP address of the email server for Cisco skills.us domain. DNS server can be quickly and transparently updated with the new IP address of the same DNS name. Primary DNS server can be configured with policy to answer the client with the IP address of the closest resource. We will look into these functions in detail in the real-world examples. Before discussing real-world example, let's look into domain name hierarchy. As you can see, this is a domain name hierarchy. At the very top is root level domain. DNS servers at the root level domain only have the records of DNS servers that own the top level domains. Top level domains include the domains such as .com, .net, .us, .vn, .gov. DNS servers at the top level domains have the records of DNS servers at authoritative level domains. Authoritative level domains include the domains such as bankofamerica.com, Cisco skills.us. DNS servers at the authoritative level domains have all types of DNS records for actual services. For example, the DNS server at Cisco skills.us have the A records for the IP address of the Cisco skills.us website, and it also have the MX records for the IP address of the email server for Cisco skills.us domain. Let's use the domain name hierarchy to figure out how a public DNS server finds the IP address of Cisco skills.us website. First of all, the public DNS server queries a root level DNS server for the IP address of Cisco skills.us website. The root level DNS server tells the public DNS server to check with .us DNS server. The .us DNS server tells the public DNS server to check with Cisco skills.us DNS server. The Cisco skills.us DNS server answers with the IP address of a Cisco skills.us website, which ends the process. Let's discuss a real-world example using this network diagram. In this example, a user logs into the client computer and types Cisco skills.us on a browser. The client computer queries its local DNS for the IP address of Cisco skills.us website. The local DNS server checks in its database or cache. If not found, the local DNS server queries public DNS server. The public DNS server checks in its database or cache. If not found, it will query a root DNS server and follow the process until it gets the IP address 184.168.131.241 and return it to the local DNS server. The local DNS server returns the same IP information back to the client. Now the client computer makes the connection to the Cisco skills.us website using the IP 184.168.131.241, which ends the process. When Cisco skills.us website changes its IP to 72.100.50.110, the chain is quickly updated to the authoritative DNS server of Cisco skills.us domain. When the client computer queries for the IP address of Cisco skills website, the same DNS query response process happens, but this time the client receives the new IP. The client makes the connection to Cisco skills.us website using the new IP. As you can see, the IP chain is transparent to the end users. When a user in Europe and another user in US open Cisco skills.us website, the same DNS query response process happens. However, the public DNS server responds to the local DNS servers with the IP of Cisco skills website related to the locations. Therefore, the Europe client computer receives the IP 195.191.200.110, and the US client computer receives the IP 184.168.131.241. So the DNS server helps redirecting the user's traffic to Cisco Skill website hosted at their locations. Let's see how DNS works behind the scene. When the client computer sends the query for the IP address of the Cisco skills.us website, it actually sends this query. As you can see, this is a DNS query, and it's query for the Cisco skills.us website IP address. The local DNS server responds with the IP address of Cisco skills.us website, and here is the message. As you can see, it is a DNS response message, and it responds with the IP address information of ciscoskills.us website. Let's sum up our video with the keynotes. DNS is a name service built on top of UDP port 53. It uses query response process to provide the IP address corresponding to the computer hostname queried by clients. Additionally, clients can query DNS servers for certain types of services for each domain name. To provide DNS service, a mapping records of name and IP address for each type of service is stored on DNS servers. Finally, DNS servers can be configured to answer the IP address of the service that is proximal to the location of the users. This is the end of this video. Thank you very much for watching.